Hello, dear students. Welcome back to the channel. So, in last class, we have studied a little bit of introduction of motion in a straight line, right? Very basic concepts: reference point, reference frame, and all. Scalar difference between basic difference between scalar quantity and vector quantity, right? So now what we are going to do is in today's class, let us do some questions based on distance and displacement. Some basic questions will do. Okay, let us see. But the thing is that before that we need to know what is distance and displacement. Okay, right? Not an issue. So let us see. So first we have position. Let's talk about position here. Okay. So we need to know a few terms. So the first term here we have is position. Now what is position? And position in a very simple word, it's a vector quantity. It's a vector quantity used to specify location of any point or object, object or body we can say, right? Simple thing. So it's a vector quantity which is used to specify the location of any point or object. So we're not going to get too much into this. This is a very basic stuff. Next we have displacement, right? Now let us see what is displacement. So you all know, I'm sure you all know, you all have studied in 9th standard. Displacement is the shortest distance. Uh, Displacement is simply the shortest distance between initial and final position, right? Are you understanding what is displacement? It is the shortest distance between initial and final position, which is a straight line. The shortest distance between any 2 point is basically a straight line. Okay, so which is nothing but a straight line. So it is a straight line. Fine. So here displacement, you have to understand that displacement is a vector quantity. Okay, and it has a formula also directly in terms of position. You can say displacement is simply change in position. Okay, displacement is equal to delta position vector, or just position you can say for now. So displacement is simply change in position. Okay, final position minus initial position, right? Okay, now moving on, next we have distance. Okay, let us understand what is distance, right? So distance is the length of the actual path traveled. Okay, what is distance? It is the length of actual path traveled. Okay, it is the length of the path that you're going to travel. So when you're going from point A to point B, So you might go in a straight line or you might go in a curved path or something like that. So distance is actually the length of the path that you take. It's the length of the actual path traveled. Fine. And it is a scalar quantity. Okay. Displacement is a vector quantity. This is a vector quantity. And both have the same unit, right? So displacement is a vector quantity, whereas the distance is a scalar quantity. Let me write that. Both are having the same unit, meter, right? Now let us see. Okay, right back on. We are there. First, what is distance? Distance is the length of the actual path travel, and it is a scalar quantity. So suppose we are going from a point A to point B. Fine, you are going from point A to point B. Fine, so you can go from point A to point B by traveling through many different paths. So you can go like this, like you can follow curved path, something like this, or you can go from point A to point B in a straight line like this, है ना? Or you can go from point A to point B in a curved path, something like this. Okay. So you have, like, suppose you are taking three different paths. This is a path one, path two, and path three, right? So what is going to happen here? Let us see. So when you're going from path one, distance will be length of the actual path traveled. So length of this curved line, this length of this curved line will be the actual distance that you're traveling. Whereas displacement is going to be the shortest distance. If you draw a line connecting A and B, this becomes displacement. Fine. So in the first case, you can clearly see that distance will be length of this curved line, whereas displacement will be simply length of this line joining A and B. So you can clearly see that distance in this case will be more than the displacement. Okay. And if you are going through this second line, if you are going through this straight line only, you are going from A to B along the straight path, then in this case distance and displacement both will be same. Okay, distance and displacement both will be same, right? And if you're going through the third path like this, so distance will be length of this curved path, fine, whereas displacement will be the straight line joining A and B. So the point is, you can see, like in the case one, distance will be more than displacement, more than the magnitude of displacement, whereas in second path distance and displacement will have same value. In third path again distance will be more than magnitude of displacement. So here we can see one general relation between distance and displacement. So in general, distance is greater than or equal to, okay, in general distance is greater than or equal to the magnitude of displacement. Fine. So in general, distance is greater than or equal to the magnitude of displacement. That's the point here, right? Okay. So meaning distance can be that equal to the magnitude of displacement or more than that. It cannot be less than that. That's the point here. Okay. Now, now what we are going to do is we are going to take a few examples. Okay. Let us see the first example. I will start with some basic examples. So first example is, suppose if I take a circle, fine. So this is a circular path. Now, if a particle goes from point A, and if a particle goes from point A to point B along this circular path, okay, something like this. The particle is going from point A to point B along this curved path or circular path, you can say. Fine. So suppose this is R and this is also R now. So suppose R is the radius of the circle. Now in this case, we need to figure out distance and displacement. Okay, in this case, we need to figure out distance and displacement. So how much will be the distance in this case? And how much will be the displacement? That's the point. Means these are the two things we need to figure out. Okay. So it's a simple thing. I'm sure you understand how to find these things. Right. Let us see. So here the distance will be length of this arc. And when you're going along a curved path or a circular path, then distance is the length of the actual path traveled. Okay. So distance will be this length. This length will be distance. So distance here will be equal to the arc length. Right. Distance here will be equal to arc length. Fine. Now this angle is 90 degrees, suppose, right? So we have a formula for arc length. Okay, we have a simple formula for arc length. Arc length is basically radius into, okay, arc length is basically radius into angle in radian. Fine. Or in short, you can say L is equal to R into theta. This is the formula for the arc length. So we can find the arc length here very easily. Here the angle is 90 degree. Here the angle is 90 degrees. So we can say the distance arc length will be radius into the angle 90 degree in radian, and 90 degree in radian is simply pi by 2. Okay, so it's fine. Thus we don't need to write that L part. So we know that the distance in this case is going to be pi r by 2. Fine. Suppose just in case you don't know how to convert degree to radian, which we'll study in basic maths, okay, or you might have studied, then you can also do like theta by 360 times 2 pi r. It's like the distance will be a fraction of the circumference, and that will become theta by 360 into 2 pi r. So theta here is 90, 90 by 360 into 2 pi r into 2 pi r is going to give you this particular answer. Okay. Now let us talk about displacement. Okay, now let us talk about displacement. Fine. So what is displacement? Displacement is the shortest distance between initial and final position. Okay, displacement is the shortest distance between initial and final position. So if I draw a straight line joining the points A and B, okay, if I draw a straight line joining the points A and B, then that will become your displacement. Fine. So displacement will be equal to under root of capital R square plus capital R square. Okay, so it becomes under root of 2 times R square. Okay, so displacement here will become root 2 times R. Clear? Here though, it's a simple thing. We get a right angle triangle. So since it is a right angle triangle, displacement will be the length of the hypotenuse, which is from Pythagoras theorem we get under root of R square plus R square. So it's a very simple part here, right? Clear? Next, we'll see. Let us take another example. Okay, then we'll take some questions later. Let us take another example. Example 2. So another similar example I'm going to take here. So in example 2, what happens? Suppose you have a circle, fine, and something like this. Now suppose an object goes from point A to point B along the circular path. Okay, it goes from point A to point B along this circular path. Like along this curved path, fine, such that this angle here is 60 degree. Okay, this angle here is 60 degrees. So our goal here is to find distance and displacement. Okay, we need to figure out how much will be the distance value and how much will be the displacement value. Okay, so let us see here. So in this case, distance will be equal to the arc length. Okay, distance will be equal to the arc length again. Simple thing, we need this length. This length will give you the distance, length of this arc from A to B. Okay, so distance will be this arc length and arc length is simply angle radius into angle in radian. So we know that. So distance here in this case becomes, radius is r, and 60 degree in radian is pi by 3. Okay, 60 degree in radian is pi by 3. So that is going to give us distance as pi r by 3. Okay, so distance will be equal to pi r by 3, right? Right. Okay, now let's come to displacement. So let us see how to find displacement here. Okay, let us see. So displacement is what? Again, displacement is the shortest distance between initial and final position. So if I draw a line connecting A and B, and if I draw a line connecting A and B, then length of this line will become displacement. Okay, length of this line will become displacement. So how to find the length of this line is, suppose this is R and R. So this will be an isosceles triangle. So this angle and this angle will be equal. So suppose this is X and this is X. So see here we are not getting a right angle triangle. So we cannot apply Pythagoras theorem as such. So fortunately in this case what happens is it becomes an equilateral triangle. Okay, if you see the triangle OAB, it becomes an equilateral triangle. How to show that is, suppose if I take, since these two sides are equal, the opposite angles will be equal, right? Now, right, opposite angles, huh? These two angles will be equal. So we know that the sum of all the angles of a triangle is 180 degree, right? So here x plus x, that is 2x. 2x plus 60 degree will be equal to 180 degree. Okay, tx 2x plus 60 degree will be equal to 180 degree. So that is going to give us 2x as 180 degree minus 60 degree, that is 120 degree, and that is going to give us x as 120 by 2, that is 60 degree. Fine. So x here will be 60 degree. Fine. Now what? So if x is 60 degree, that means that that is not the answer. That means that OAB is an equilateral triangle. So displacement will be equal to the length AB, and which will be equal to OA and OB, which are nothing but the radius. Okay, so displacement here will be equal to the radius r. Okay, so distance will be pi r by 3, whereas the displacement will be just r. Oh, displacement is going to be just r. So that is the point here, right? Okay. Now what we'll do is we'll just see one general formula. Okay, so it's not necessary that always you'll get Pythagoras theorem or always you'll get an equilateral triangle as such. That is also uh, not necessary, you know. Now suppose like the angle is 45 degree or 30 degree or some general angle in for that matter. Then how will we find distance and displacement? Okay. So example 3, let us just let's not call this an example. Let us just call it a general formula. So let us see a general formula for finding distance and displacement. Okay. Let us see a general formula for finding distance and displacement. Right. So let us see here. So this is a circle. Now, so suppose you are going from point A to point B. Okay, you are going from point A to point B along this curved path. Okay, you are going from point A to point B along this curved path, and suppose this is the center of the circle O. This is R and this is R, and let us say this angle is theta. Fine. Now what you need to do is you need to find distance and displacement. Okay, what you need to do is you need to find distance and displacement. So let us see in general the distance. So distance here will be, again if I see the general formula, distance will be simply this arc length, and distance will be just this arc length L. So distance will be arc length, and arc length is simply radius into angle in radian. So distance here theta should be in radian. Okay, so distance becomes simply r into theta. Theta should not be in degree, theta should be in radian. Okay, so distance here will be equal to simply r into theta. So that is the point here. Okay, now let us see displacement. So this is distance r into angle in radian. Displacement in general, if I try to figure out, so displacement is the shortest distance between initial and final position. Hai na? So if I draw a if I draw a line joining point A and B, then length of this line will become displacement, right? So now how to find displacement? So we have to just do a little bit of analysis here. So we need to figure out this the length of this purple line. So see, if I draw that triangle OAB separately, suppose this is the triangle OAB, and this is the purple line here, which is representing the displacement. Okay. So this is O, this is A, and this is B. Okay, this is R, and this will also be R, and this angle is theta. So from here, if I drop a perpendicular like this, so this angle and this angle will be equal. This angle will be theta by 2, and this angle will also be theta by 2. Okay. The displacement is going to be nothing but the length AB. So from here to here, uh, so I have dropped a perpendicular here. So since this is an isosceles triangle, the perpendicular here becomes perpendicular bisector. Okay. So this length here will be, let us say this length is x, and I'll name this point as some c. Okay. And this length will also be x, and let us name this point as some c. Now if I see the triangle OCB, okay, in triangle OCB, so if you see a triangle OCB is a right angle triangle, है something like this. This is O, this is C, and this is B. This angle is theta by 2. This is X, and this is R. Okay. Now if you see in this triangle, sine theta by 2 will be equal to X by R. No, sine theta by 2 will be equal to X by R, and that will give us X as R sine theta by 2. Fine. So the displacement is going to be 2x. And we need the complete length AB. So displacement will become 2x, and x is nothing but r sine theta by 2. So in general, the formula for displacement becomes 2r sine theta by 2. Okay, in general, the formula for displacement becomes 2r sine theta by 2, right? Clear now? So this is the formula for displacement in general. Here if you see, if theta is 90 degree, okay, if theta is 90 degree, then the displacement will be equal to 2r sine 90 degree by 2. 90 degree by 2 is basically 45 degree. So it becomes, you know that sine 45 degree is 1 by root 2. So how much will that be? That will become root 2r. So you can see that if theta is 90 degree, then displacement becomes root 2 times r. And if theta is 60 degree, like we have seen the second example, displacement will become 2r sine 60 degree by 2. 60 degree by 2 is basically 30 degree. So 2r sine 30 degree, which becomes 2r into 1 by 2. So displacement will be simply equal to r. So which is matching our answers earlier. So you can see that this general formula is legit, right? It is valid for everything, right? Great. So You can understand the formula. In general, in circular motion, distance is r into theta, where r is the radius and theta is the angle in radian, and displacement becomes 2r sine theta vector. So these two results are important. Okay, right. So I hope you understood everything. If you have any doubts, you can put it in the comments, and I'll try to answer there. And anyhow, we are going to continue this chapter in the next class. Okay, so we will be solving some more problems based on distance and displacement, and then later we'll move on to average speed, average velocity, and all. Okay, so for now I'll keep it till here. Okay, so I hope you liked it. I'll end this session now. Okay, bye bye.